Okay, today, graphs of polynomials. I want to kind of give you the big picture here. This is a very complicated looking thing, and I'm going to ask you to read through it in just a moment, but that is a description of a polynomial. You know, when you started algebra, life was simple. There was no squares. It was just like this. You know, and you solve for x and you get one answer, right? What happened when you started getting squares? A lot of times you got two answers. Okay? And we did a lot with squares. These are quadratics. You learned that you could use the quadratic formula to solve them. You learned that sometimes when it was like this, what was the solution for that then? Imaginary. And how many imaginaries would there be? Two. So you could say there's no what kind of answers? No reals. Okay, but we could get two imaginary solutions. Okay, so that happened when we had things that were squared. Would you want to make any guesses? Yes. There's three answers. Yeah. This is called the fundamental theorem of algebra, is that basically that tells you how many solutions you have. Okay? It's the biggest degree of all the terms. All right, so let's talk about this in the context of this. I want you to read this over thoroughly, carefully, and try to catch the rules to be a polynomial. Not everything complicated looking is a polynomial. Please read this over carefully and try to figure out which of these, 1, 2, 3, 4, 5, and 6, are not a polynomial. And I want you to just go like, oh, you are not a polynomial. Cross them off, okay? But you don't know until you've read the directions. While you're doing that, I'm going to be pairing you with somebody that you're going to work with on a harder problem in a minute, and I'll have you do the other part later. So pause for a second while I pair you, and you try to figure out which ones are not polynomials from reading. So let's see who the die of destiny chooses. It's row 6, person 2. That'd be you with the hat, which you can remove, please, and put on the ground. Thank you. All right. Ooh, bad hair day too. No, it's just a few stray ones on top. You're fine. Okay. So, did you find one you thought was not a polynomial? Number 5. You're thinking it looks strange. It can't be a polynomial. Can you be specific? Which of these rules did it break? Did it break this one? Did it break this one? Domain has to be that. Or does it break this one? See, those are the three main rules. I know it looks weird, but does that necessarily mean it's not a polynomial? If it's not constant, okay, so what has to be a constant in here? That's the constant. Do you have to have a number at the end to make this a polynomial? Nope. So if I have like 3x squared plus 2x, it doesn't have to have a number that's a constant at the end. That's a polynomial. All right, so we don't have a requirement there. Okay. What it's all about to be a polynomial, and by the way, when we're covering this stuff, we're covering future test questions, okay? So what makes something a polynomial? I'd rather think of it as what makes it not a polynomial. All right, so n has to be greater than or equal to 1. Where's that? What's the n? In simple words, tell me what's the n. What in a polynomial is the n? That exponent right there, which is the biggest of the exponents, because all the other ones are going to be like n minus 1, etc. Okay, so the biggest exponent has to be greater than or equal to 1. Are there any of these that would break the rule because of that? Yes, sir. Number 4, he says, this one has an exponent of, can you do it? Very good, x to the 1/3. In case you'd forgotten, the third root means x to the 1/3. Perfect. Therefore, not a polynomial. because you're supposed to be 1 or bigger. Can't have fraction exponents. Yes, sir. Number 6, why? Perfect. It's like degree 0. And degree 0, not a polynomial. Crossing it off. Yes, sir.
How do you know it's not? How do you know, like, if it's in the form a of x? How do you know it's not a? It's just not 0. It's 0x cubed or something like that.
Okay, if I have 0x cubed, that means I have none of them, and therefore they don't exist. Otherwise, every polynomial, if you think about it,
Yeah.
if I had 2x squared, it could have an extra plus 0x to the 5th in there.
Yeah.
Okay, you can't do that. If it's got a 0 there, that means that it can't exist. And how come it can't have a 0 there? It says that a sub n, where n is this important number that's also here, can't be, n equals 0 means degree 0 and therefore not a polynomial. I can't have a 0 here, or if I do have a 0 there, it's not a polynomial. Okay, so you can't do this 0 5x or 0 times x to the 5th, because that would mean that that's not a polynomial. It's defined right in there. All right, there's a couple more that are not polynomials. We've crossed off a few here. Can't cross that one off, sorry. It's, which one? Well, we haven't yet, anyways. Okay, you can give me a reason why we can in a second. All right, want to give me a reason why you think we can cross off 5? All right, I want to make a little sketch of this, and I want you to tell me, again, is the domain from negative infinity to positive infinity? Okay, but good try, though, because we hadn't used that domain thing yet. That domain rule is kind of waiting. Yes? All right, you want to cross off 1 and 2. That's a lot. How about 1 at a time? Which one do you want to cross off first? Okay, because why? Do you get how 0 cannot work in this function? And therefore, if 0 can't work because it's going to crash the function, therefore, it does not have a domain of negative infinity to positive infinity. Awesome. I agree. Next one. You want to cross off the next one too because it can't be 0? All right. So, you're right, but this one's a little more complicated. Let me factor it for you. If I take an x out, remember my rule, if you can factor it, you should. 4 plus x to the 3rd. All over x. This x is going to cancel. Oh, thank you. That x is going to cancel. If that x cancels, it's not even there anymore. And therefore, does it still have a domain of negative infinity to positive infinity? No, because if I put, just prove it to me. If what? If you put in a 0, it's still going to crash it. No matter how you factor it, Mr. Server, it's still going to be something over 0, and therefore I can't allow it because it doesn't have a domain of negative infinity to positive infinity. Holy cow, is there anything left that is a polynomial in here? Well, this other one here, let's factor it again. If you can factor it, you should. Everybody please factor that. And then when you're done, turn it my way, and I'll tell you if you factored it right or not. You know what? I'm realizing these are going to be really small, and it's going to be hard for me to see if you've canceled things properly. I'm going to have you compare with the kid next to you, since you're going to be working with them in a moment. Compare with the kid next to you and see if yours is canceled the same way that theirs is. Maybe there isn't even any canceling you can do. Maybe you can only factor it. X plus x cubed. 4x plus x cubed. Okay. Factor the top for me, Mr. MF. Yes. I agree. Did that make you think about how, wait a minute, there's an x squared plus 4 on the bottom. It's just rearranged. So if I rearrange it just to make it look nicer, can I do that? Am I allowed to do that? Sure, and now this is the same as that. Or I could have rearranged this one and put the lead coefficient bigger in front. That would be even better. We'll talk about that in a minute. And cool, it's just x. So therefore, since this equation is just y equals x, is that a polynomial? Okay, try again. Why? All that factoring and stuff can just deceive you into thinking that there's no issues with the domain. Yes? Okay. Because I have to go back here and figure out what could crash it. So do you have any thoughts on what could crash it? Nothing can crash it. You would think something could crash it if you at least thought about it. Could you possibly make something, an x, make the 4 turn into a 0, like make that -4? But then you're saying you want x squared to equal -4, and is that even possible? And therefore nothing can crash it. And therefore, since nothing can crash it, I don't have a domain issue. And therefore, I am okay to say that that is a function. Or excuse me, it is a polynomial. All right, enough about what is and isn't a polynomial. I'm going to do this next part without the fancy wording. I'm just going to tell you from an example or two how to find the degree, the leading term, the leading coefficient, and the constant. Okay? The degree, you just find the biggest power. If it's all multiplied out, it's that simple. So, do you get that that one is degree 9? Okay. Then that one really should have been in front. Do you get how when you write these, you're supposed to put them in order so that the biggest one is in front? So we kind of cheated just to throw you off there. A lot of people will grab that first one and say, 6 got to be the degree because it's in front. No, not necessarily. It should be in front, but it hasn't been done yet. Now, that makes this in front, and I'm going to move this back later. It doesn't even really matter when it comes to the leading coefficient. The leading coefficient then is 3. Does it make sense to you? The 3 is the number on the x. That's the lead coefficient. Okay? And this is the leading term. What's the last thing we got to know? The constant. The constant is very simple. It's the thing that doesn't have an x. Okay, what if it doesn't have a constant? Then the constant is 0. Very good. All right, so I'm going to give you one. See if you can. Actually, let's just use some of the ones that are in here. Look at number 1 on the, what is that color? Teal. On the teal slide. What is the degree? Say it if you know it. Degree 5. What is the lead coefficient? 4. And what is the leading term? 4x to the 5th. And what's the last thing called the constant? Very good. Okay. Let's get the trickier one. This one's just too easy. All I did is move that to the back. We could simplify that super easy. But how about this one? So we have to make it look like the other ones. Do you get that I'm going to rearrange this and say -x plus 4 over 5? And do you get that I can divide them separately by 5 and say -x over 5 plus 4 over 5? And then I'm going to write it one last time and say -1/5 x plus 4/5. When I write it that way, isn't it easy to tell what degree this is? And what's the lead coefficient? Okay, what is the lead coefficient now? -1/5. And the leading term is this whole thing. And then its degree is degree what? 1. All right, here's one. Polynomial or not? Remember, it has an x to the 0 there if that's going to help you. Are you allowed to have that as a polynomial? No. Nope. This is not a polynomial. That is an equation, but it's not a polynomial. It has to have at least an x in it, which means x to the 1, okay, to be a polynomial. Poly means many, right? Yeah, that another reason why this shouldn't be a polynomial? Y equals 5 or x equals 5, either way, it doesn't really matter. Yes? Ah, interesting, domain. But if you're right on the x equals 1, but on the y equals 1, y equals 5 does have a domain from -infinity to +infinity, so that's actually not a domain issue. But the 5 has only one term, and if poly means many, how can it be many terms if you only have one. Okay. All right, moving on. This is an application question. It's going to be a challenge, but I'm going to lead you up to it by having you do an easier one first. Grab your graphing calculator and slide over so your desks are not touching but close with the person that I paired you with. I'm going to fly by and grab your tests real quick. If you want to, you can always ask me to get it back at the end of the hour. No, I am going to be grading those tomorrow because we have too much to do today. I'm not going to collect that worksheet until tomorrow. Thank you. Thank you. All right. I want you to look at, sorry, I'm in the middle of something. I want you to look at the test, please. Thank you. I want you to look at the tough polynomial problem on the board. Talk later. Thank you. As with all tests, these can be retaken. This did count on second quarter for those of you that care. And for those of you that want to do a retake, you can do corrections on the test by coming in the morning. And then some other morning, I can throw it in the testing room, or you can take it here and you can do the test corrections and then retake. Yes. But it's for second quarter. All right. So you've hopefully had a chance to start reading this question. Now this one would be a tough one without a little bit of guidance. And given the amount of time we have left in class, I'm going to just give you some overall guidance and then have you try this problem. Your homework for tonight, in case it gets crunched at the end, I'm going to tell you now what I want you to do for homework for tonight. Okay? But this polynomial problem in class is very important. You need to know how to do this. All right, but back to what's your homework. Flip to this, and it says, notice we got one of those 2 lessons in one day thing. So as soon as we hit here, that's starting the second lesson. The homework starts on, and would somebody please figure out what slide this is? It says slide 16 for you guys. Thank you. So on slide 16, you start right here. And I do want you to do 2, 5, and 7. And these are making a sketch of these polynomials. So I think I'm just going to have you do 2 of those. These 2, you may skip 25. And a word problem. I think it'd be good for you to do a word problem. We're going to do 32. All right. No more after that. You'll live. All right. Moving on to I can't find my problem. Where is it? Thank you. Okay. Would you agree that we can start by drawing a picture, but in this case, they drew it for us? But then what was the second thing I said about word problems? You should always start with the base, go ahead, base equation. What are we talking about here? Volume. Do you know the base equation for volume of a picture like this? What is it? Say it if you know it, Mr. H. Yes, I'm going to change a letter on that. I'm going to go with length times width times height, but you can do, actually base probably would have been just as good. So length times width times height, and I do need the what at the beginning? Equals V, or I'm going to say V equals. All right, everybody needs that. You need that. Because now, really, your life isn't that complicated. You just got to figure out what do we want the volume to be, and does it say anywhere in this question, we want the volume to be blah? I don't see it. Okay. Then that means we're just going to try to figure out either a minimum volume or a maximum volume. Does it say anywhere in here whether you want to find the minimum or the maximum? Yes, sir. It says to find the maximum volume. So how do you do that with a calculator? How do you find a maximum using a calculator? Graph, and then so let's say the graph looks like this. Well, there's an obvious point that seems like it's probably the answer is like right here. It's the maximum. Or if you follow the end of the graph up, it goes forever, right? And what you just said is really important, Mr. Z. You said something about the, figure out the what? The constraints, okay? So like the requirements. And like what if, do you get that we don't want to go into the negatives? Why don't we want to go in the negatives? Can't have a negative volume, can't have a negative length of the box, all right? This little thing right here with the x's is another part that's really important. Do you think on the x you could have a little cutout that's infinitely large? Can you have an infinitely large cutout? No. Think about it for a second. On the requirements for the x here, if it's going to be like from 0 to infinitely big, no, it's going to have to stop somewhere. What's the biggest that x could be? Well, let's go with this. It's 10 inches wide this way. Do you get that kind of tells you the biggest that x could be? What are you thinking, sir? Why can't x equal 5? You'd be cutting out so much that this would be 5 and this would be 5, and you wouldn't even have a box anymore. You get how it can't be 5? It has to be less than 5? Do you get how that's important to think through? That's what most of you guys did wrong on your last test, is you didn't think through what x could be. All right, so you got to know what the requirements are for x. And the last thing is, we just have to write an equation to be able to graph it. All right, so what equation should we have? Let me give you a hint. You need x, L and W and H, but you need it in the context of this drawing. That is like your length. That is like your width. And what is your height of the box when it's all put together? All right, enough people know that I think we can do this. All right, you have the next 9 minutes to try to figure this out with your partner. If you have things like, oh, I know what the height's got to be. I know what the formula for this has got to be. And I'll give you a hint. It's not 12. It's going to shrink because you're cutting out part of it and folding the box up. This side is not 12. It's less than 12. This side is not 10. It's less than 10. You need variables. Figure this out. Once you've got it, it won't be tough to graph it and figure out your answer. Okay, go for it. All right, so I have my first person attempting to tell me what the equation should be. We have an x here, and then he says we should multiply it by 12 minus 2x. How many of you had that as as part of your equation? Awesome, awesome. So that 12 minus 2x, as soon as you get that, then you know the other side too, right? So go ahead. Times 10 minus 2x. Why are we subtracting 2x's? That's the number one mistake. People just think they want to subtract x because there's an x on both sides. There's like a little bit of x here and there's a little bit of x here. So this isn't just subtracting 1x from it. You got to subtract 2x. Okay, good. And then this is really important part. If I hit graph and I can't see the graph, what's probably wrong? Window. Okay, so let's hit graph and see what happens. Where is it? I can't see it. Okay, so then I go to window. And then, you know what? How to get the standard? Oh, wait a minute. Look, I can see it again. But you know how to get the standard zoom? Zoom 6. In case you haven't learned that trick, it's pretty cool. Zoom 6 gets you the standard zoom. All right. And now it's graphing it, and it looks like, ooh, yay. It kind of goes up and down and then back up again. So how am I supposed to know where to stop? Help me go from here. Like, can I just pick the highest spot it ever is? Yes, sir? Ooh, this is interesting. I don't know where you're going with this, but I'm going to try it. I'm going to calculate value. X equals 5. Let's see what happens. And it says y equals 50. That means it's not even on my screen. So maybe I should go up higher, right? So I'm going to go to my window. Wait. I'm just following his train of thought for a moment here. Y maximum. And I'm going to make it, instead of 50, always overshoot. I'm going to go like 70 or something. Okay. And then I'm going to hit graph again and see if this helps me see it better. Okay. Now, I like the idea of finding out where x is the biggest, because that is an endpoint. Do you get that? If x is the biggest at 5, 1, 2, 3, 4, 5, it's like right there. That's the biggest, my alignment's off, but that's the biggest x that we can have. We know that's our rules because of the picture. So then, do you get it's got to be somewhere between what and that? What's the smallest it could be? Smallest x in the context of this picture. 1 is a logical number, but we can actually be smaller than 1. What do we have to be bigger than? 0. Okay, good. So there we go. It's got to be between here and here. So what we're saying is we want the maximum between there and there. Yes? We do at the very beginning. Okay.
Why is there no 2x?
Because I made a mistake. Thank you very much. That's really important. I need to get, hold on. Let me get that fixed. One thing at a time. So I'm going to go 2x. Thank you for catching that. Yikes. And then a parenthesis there. Where is the in parentheses? Okay, good. Now I'm going to try regraphing that puppy. And it's still, I have those same constraints. X has to be between 0 and 5. But my picture is going to look a little different. Thank you. Now anything to add about that? Any questions? Yes, sir. Okay. Does it look to you like the highest that our graph ever went is at x equals 5? No. Yes, ma'am. I agree. We could do this with the table, but I've come this far with the graph that I'm gonna finish the deal. Why can't I see the answer? Yes.
If x is 5 and volume is 0.
Yeah, if x is 5, it's getting to be a really, really small volume. That's not like a really, really big volume. Do you get, I want a spot that's like somewhere up in there? Yes? All right, but I need to be able to see it. So I'm going to change my window first, and then I'm going to do what you just said. So I'm going to go up higher. I'm going to go to maximum of, let's say, 120. Remember me saying you should overshoot? I should have overshot even more. And now I'm going to say, okay, what's the highest this ever gets in between the two red lines? Do you get the highest point is kind of sticking out now? It's that highest spot. How do you find that? Second, calculate maximum, number 4. And in case you've never done this one before, when you're doing the maximum, it does not just jump to the highest spot. You have to say maximum between where and where. And I'm going to say to it, since I know it's in between here and here, I'm gonna like narrow it down for it and say between here, and see how for my calculator it puts in a neat little line to there. Now granted, it's those red lines, but you and I know it's gonna be between those two, right? And the guess is like get close. There. Boom. And it jumps to the exact maximum, which is at x equals 1 point, what is that? I can't read it. 1.81. And what is the maximum? 97. All right. That's what your word problems are like. We're just beginning to learn them. You have a test on this a week from now. We got a lot of chance to learn between now and then. Have a great day.